have it. Okay. So, and we're going to be talking about this a lot throughout the rest of the year, but the empirical rule. Okay. This is what we're learning right now is the empirical rule. So this is the scores taken by 213 students on a 20-question test. Now, you'll notice there's 213 students. This is a frequency table, just like we just did. One person got a 1. One person got a 2. 5 people got 3s. 16 people got 7s. 16 people got 14. So if we were going to make the histogram on our calculator, we would have to do a list 1 for the variable, which is the score 1 through 19, and then a list 2 for the count. Okay, but this is what the histogram looks like. So they're giving us the histogram, which is nice of them. So there's the histogram. What do you think? Roughly symmetric, unimodal and symmetric, would you say? I would not call that skewed. I would call that symmetric. Everybody kind of okay with that? Yeah? Okay. So what we want to find out right now is how many of the scores fall within one standard deviation of the mean. So we're going to give standard deviation a little bit more of a meaning right now. So they're telling us that the mean score was 10.221. So this is 9, 10, 11, 12. So here's your 10s. So the mean, I'm going to draw a line like right about there, okay? And I'm going to call that X bar. And I'm going to write that, that's 10.221. And they're telling us that the standard deviation, that is the average amount that the data is from the mean, is 3.859. So we know that some of the data over here is, well, I mean, if my mean is 10.221 and somebody got a 1, I mean, that's clearly more than one standard deviation away from the mean. Way up here, somebody got a 19. That is more than one standard deviation from the mean. Well, over here, somebody got an 11 and somebody got like a 9. Well, those are less than one standard deviation from the mean. Because remember, the standard deviation is the average amount that a piece of data is from the mean. So if it's the average amount, it means that some are going to be greater than the mean, greater than that average amount, and some are going to be less than that average amount. That's why it's an average amount. Okay, so one standard deviation, the average distance from the mean is 3.859. So I'm going to take my mean of 10.221, and I'm going to add one standard deviation, 3.859. And I find out one standard deviation away from the mean is, see, this is 12 through 14, is 14.08. So 14.08. And one standard deviation below the mean is, so minus 3.859. 6.362, so 6.362. So here's my mean. Here's one standard deviation greater than the mean. And here's one standard deviation less than the mean. So I want to find out how many scores fell within one standard deviation of the mean. Meaning, if here's my mean, I want to know all the scores that fell within 1 standard deviation above the mean and 1 standard deviation below the mean. I want to find how many scores either above or below are within 1 standard deviation of the mean. So if I want to do that here, I'm going to have to do some counting. So we know 10.221 is our mean, and we know that 14.08 is 1 standard deviation above. So all the scores that fell in the 10s plus the 11s plus the 12s plus the 13s plus the 14s, all of the scores that fell in these bins, that one, that one, that one, and that one, see, wait, 10, 11, 12, 13, and 14. So I guess it has to include this bin too, because because the scores are integers. So all the people in this bin right here, all these people in this 14 bin were less than 14.08. I'm going to say that again. Since you can't score a 14.08 on the exam, you're either going to score a 14 or a 15. So if 1 standard deviation above the mean is 14.08, everybody that scored a 14 falls within 1 standard deviation of the mean. Does that make sense? Yes, everybody clear on that? Okay, so these bins here, I need to add them up. So let's get the numbers here. Do I have the numbers? Yes. Okay, so I said I needed 10, 11, 12, 13, 14. Okay, so 10 had 32 plus 17. So there's 32 plus 17 plus 21 plus 12 plus 16. So let's add those up. I got 32 plus 17 plus 21 plus 12 plus 16. So I had 98 people scored within 1 standard deviation above the mean. Okay, so 98 people. Let's write that on our histogram. Come on, calculator, get out of the way. Let's write 98 right here. And now we're not going to count the 10s again, but we're going to count the 9s, the 8s, and the 7s. We're not going to count the 6s because 1 standard deviation below the mean is 6.362. And if you got a 6, you're not within 1 standard deviation of the mean. And does that make sense? Little bit hard to get my head around sometimes. But I can't score a 6.362. I can either score a 6, which is less than 6.362, or I can score a 7, which is greater than. So I really can only add the 7s, the 8s, and the 9s. So the 7s, the 8s, and the 9s are, wrong one. So let's make a different color. So 7s is 16 plus 15 plus 17. And that's 48. So I have 48 that fell below the mean. So I just want to make sure I'm doing what they want me to do here. Yep. So I want to know what proportion of the scores are within 1 standard deviation of the mean. So I'm going to take 48 plus 98, and I'm going to divide it. Well, first I'm going to add them together. And then I'm going to divide that by the total of 213 students. Divided by 213. And I get 0.685. So 0.685 fell within 1 standard deviation of the mean.
I have a question.
Please.
Why wouldn't 10 be included in the lower, like the amounts below the standard mean?
So my mean, what you mean, why wouldn't it, or why, or so okay. Ask the question one more time, Mila.
So you have two sections, the standard deviation above and the standard deviation below.
Right.
Why isn't the 10 included in the standard deviation below?
You know, it should have been. My bad. Because you're right. If the mean is 10.221, then this should have fallen over here. You're absolutely correct. So when we get back into the classroom, you get to push the fish button. Do you know about fish? Did I talk to this class about fish yet? Oh, okay, well, you remind me and we'll talk about it later, but you get to push the fish button. It should have been included in the one below. So if we actually did that, let's actually do that. Let's take our 10. And so our 10 is 32. So if I take our 32, so I go 48 plus 32, our bottom really should be 80. So this should be 80. And if I take off 32 from 98, 32 should be 66. Okay. The important thing though here is the combined number of 146. That's what's important right here, is the combined number of 146. That's the important number. And which is kind of, yeah, but you were right anyways, technically, you're absolutely correct. Okay. But the combined number is what we're most concerned about, because that is the number that falls within 1 standard deviation of the mean. Okay. So I did this for the others. I wanted to find out how many of the 213 scores fell within 2 standard deviations of the mean. So let's just do the calculation here. If my mean is 10.221 and my standard deviation is 3.859? Yeah, 10.221, 3.85. Yeah, right. I'm multiplying 3.859 times 2 to find out 2 standard deviations of the mean. So I'm going to go 10.221 plus 2 times 3.859. And I get 17.3939. That is 2 standard deviations from the mean. Oh, what's wrong here? Something's wrong. Yeah, that's 2 standard deviations above the mean. And if I go 10.221 minus 2 times 3.859, I get 2.503. So 2.5, 17.9. If I go back to my diagram here, 2.5 would be somewhere like, let's make it in blue, somewhere 2.5 would be right about there, and 17.59 would be somewhere like right about there. So this distance here is within 2 standard deviations of the mean. Is this making sense graphically? Are you seeing, you understanding what we're talking about here? I'm seeing mostly yeses. Okay. So if I add those numbers up, I find out that 0.948 is the proportion of values that fall within 2 standard deviations of the mean. And if I went 3 standard deviations of the mean, it's actually covers, well, from negative 1.13, which you can't get because the scores are between 0 and 20, and 21.798, which you can't get because that's higher than the highest score. So 100% of the scores are within 3 standard deviations of the mean. So to totally blow your mind here, okay, the empirical rule says, and we will go over this again next time, but if I have a distribution that is unimodal and symmetric, and it doesn't have to be exactly, but pretty much, and here's my mean, I draw it just like this. I go my mean, and then I go 1, 2, 3 standard deviations positive, 1, 2, 3 standard deviations negative. So here is 0 standard deviations from the mean because that is the mean. Here's +1, +2, +3. Here's -1 standard deviation, -2 standard deviations, -3 standard deviations. And what the empirical rule says is that if I have a distribution that is unimodal and symmetric, between -1 and 1, pretty much 68% of the data is going to fall between -1 and 1. 95% of the data is going to fall between -2 and 2. And 99.7% of the data is going to fall between -3 and 3. So the empirical rule says 68, 95, 99.7. And in fact, sometimes it's called the 68, 95, 99.7 rule. All right, we're going to stop there. So you can dream about that tonight, you know, and on Monday, we'll kind of get back into it. But this, I mean, if you can just imagine, I mean, it doesn't matter whether a distribution is like tall and skinny or really spread out. They all have standard deviations, and no matter what the distribution looks like between -1 and 1, 68% of the data is going to fall right in there. It's astounding. Really, it's really kind of astounding. Yeah, so we'll be using that to make a lot of really interesting calculations. So we're starting to get into the good stuff right now. We're going to be into z-scores pretty quick. And yeah, we're going to be able to compare apples and oranges and all that stuff. All right, so we will see you on Friday. Have a nice rest of your day. Adios.
Thank you.
Thank
Welcome.
you.
You're welcome.
Thank
See you
you.
later.